All right. Welcome everyone to day 20. So what's the problem today? It's about flip-flop modules. Okay. Conjunction. Okay, so we are connecting cables and they have modules. And they communicate using pulses. So they have high or low pulses. Destination modules. Okay, so flip-flop modules are either on or off, and they're initially off. And then it flips. If it receives a high pulse, it is ignored. If it receives a low pulse, it flips. Conjunction modules, they remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates in memory for that input. Then, if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. Okay. There's one broadcast module, and it sends the same pulse. And you have the button module that you press and sends a low pulse. Okay, so they're always processed in the order they ascend. Okay. We're sending a bunch of signals, and then... Okay, we can look at this later. But the end goal here is... we press a button. So basically, what's going to happen is that we have this state. We're going to say, Merry Christmas, Gretlin. Thank you for tuning in. And so what's going to happen is we're going to... right, so let's see. So, we send signals again and again and again and again. And then in the end... and then we complete a cycle, right? And then... all the modules are in the original state. So we push the button 1,000 times, okay? And then we calculate how many low pulses and how many high pulses are sent. So we are going to just remember the state and then find the length of the cycle and then figure out how many pulses how many button presses it takes for one cycle. Let's get to it. So here is our first input. Let me rewrite this. CD day 20. Make dear day 20. CD. I configured it. Day 20. GCO. Day 20. WJS. GC. Day 20.js. Day 20. 03. And day 20. We're gonna time it. 02. Okay. Let's start. Language GC 2021. Module main where? Main IO. main equals return. Okay, so now we are gonna say do read file example print.parts. So what is the state? So a module, data module equals. So we have a flip-flop module, flip-flop, and this is going to be on off is bool. So whether it's is on. So this is going to be a bool. Right. So is on. They're initially off, and ignored, nothing happens. Or if a flip-flop is a result of flips between on and off, if it was off, it turns on and sends a high pulse. Okay. So I think, and now we're going to say, so this is a, there are cables between the, modules. So let's see here. Connections. It's going to be a list of ints. I'm going to use an int map here. Okay, so this is one kind of module. We're using sum types and row types, I think they're called. Anyway, a conjunction module. Conjunction is, so they don't have this is on thing. Conjunction, remember the most recent impulse received from each of their connected input modules. They initially default to remembering low impulses. When a pulse is received, so it's going to be a memory. A conjunction memory is going to be int map bool. Let me import data.intmap. Intmap qualified .intmap as I am. So they have a memory, and they also have connections. Okay. Then if it is blah blah blah, okay. There's a single broadcast module. When it receives a pulse, it sends the same pulse to all of its destination modules. Broadcast connections int. Let me see. Let me get the. So I think the broadcaster is always going to be first. Oh no. Okay. Broadcaster is not always first, but I can just move it around. So we have connections and they're ints. Let me actually Okay, anyway, let's say here broadcaster. Okay, so instance show module where show flip flop C is equal to let's have it remember the okay, I'm just not going to show them. I'm just going to do deriving show, okay? Deriving show EQ. And we're going to say parse module, taking one line, and we are going to say queue the module. So parse module string. Let's look at the first character. So if the first character is B, then we are defining a broadcaster. What does a broadcaster look like? We say mods. Okay, we're gonna need split on also. So we're gonna say drop length str drop length broadcaster string, and then we are going to say mod list is equal to split on comma of mods. Okay, now these are going to be let me see. I'll just throw out the spaces. Filter not equal to space. And then we are going to say is there like a hash function for ints? String to int. Let me just write the hash function here. We can use the ord function. Data.ord string to int. hash equals a hash prime, and let's start at 0. Where, and then the multiplier, so this is the power of, okay, so hash, so this is cur, and this is a power. Empty is c, hash prime, c, p, let's say cur, cr is equal to hash prime cur plus ord c times 10, because I think they're all to the power of 2p times p. I think we can do it like this. Let's just do it like this. Increase p by 2 and then r. Let me see. Data char ord. Let's see. Map hash a to z. Let's see, let's create all the combinations. A, B, A, B. Okay. So it seems like it does go longer. Let's make this 3. Okay, we made a hash. So set is 122. Okay, and now there's no collisions in the hash. of the names. I don't know why we necessarily went this way, but we did. Let me see, and they are all 2-letter names. It would also work actually for inv. Okay, okay, so parse module, this is going to be broadcaster. Map hash a mod list. Let me just tell Anandi something. Okay, so this is for the broadcaster. If it starts with string, it starts with a percentage sign, then we are defining a flip-flop. Then we're gonna say we're gonna say here nm is rest is span not equal to space of string. Okay, and then we drop this mod list split on filter not equal to space of drop length space narrow space of string. No, this is rest. Okay, and this is equal to flip flop. False, so it's off. Map hash mod list. And exactly the same for the conjunction, except here we have the and sign, and then we're going to have a conjunction. It's going to have an am.empty as the initial memory. Read file example print parse a, let's see, print, and also in the input, like, yeah, nothing is connected to the broadcaster. It's just on the left hand side. Print dot map parse module dot lines. I forgot to save it. Okay, let me see. Let's say map and print. So we got the broadcaster connects to A, B, and C, and then A connects to B, and B connects to 9, and then C connects to let's actually have the ID here also, just so we have it. MID is an int. MID int. Okay, and then we're gonna say here, this is gonna be module ID 0. It's gonna be hash of enum, and this is gonna be hash enum as well. Okay, I want to make it look a bit different. Ding, 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 ding. Buddy. Okay, now let me not derive show. Let me say here, okay. Instance show module where show broadcaster. I don't care about the ID here. Cons is equal to and that's just then print broadcaster. And then I'm just gonna show the connections. I'm not gonna recover the name. I'm just gonna use the digit. Okay. This is and show ID. And the same here with flip-flop, but we are going to have the percentage sign here. Nice. Okay. We've done the parsing. Now, ding, ding. Now let's create the state, which is just going to be, so let's see, part 1. This is strings, and okay, we're not going to say that yet. Part 1 is dir is equal to where modules is equal to map parse module dot lines stirs part 1. And now let's just print it. And let's do IAM.from list map. We have here a module. We just want to go MIDM, comma M. Okay, and now we have all the modules in the list. Okay, now I would like to initialize the conjunctive memory so that we don't have like a map.empty. Let's see, do we even need... Remember the type of the most recent pulse received from each of the connected. So they remember low pulse. When a pulse is received, the conjunctive model first updates its memory for that input. Then if it remembers a high pulse if it remembers high pulses for all inputs. Okay, so we need to know all the inputs to that to that module. Okay, so let me see. So we have the we have the modules here. And now I want to say so first I want to know the IDs of all the conjunctive modules. So then I'm going to say is conjunction true, is con is equal to false. Let's see, then con IDs is equal to a map MID dot MID on filter is con modules. Okay. Now for each of these con IDs, I want to say connected con input takes in a con ID and we get all the input. So you say let me see. So it also sends to all of them in order. So it always finishes sending all of them, right? So I think these connections should actually be a set. So we do here is.fromList, 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 import qualified data.inset as is, import data.inset. What happened there? Line 64. So con input con ID is equal to filter, and then we have for each module we have we're gonna say connections and we have is.member key inset con id dot connections, and then we just want the map the NID of those. Okay, so now I'm gonna say map con input. So then I can tell which ones. So now I'm going to say add inputs. And so for any module that's not a conjunction, we just return the thing. Add inputs a conjunction. Let me see, I always forget how things are defined. So add inputs conjunction MID, and we don't care about the current memory, and we don't care about the con. We know we have to keep the cons around. Is equal to conjunction MID, and then I want to initialize I'm just gonna say from list zip con input MID with repeat false. Cons. Okay, now modules. Let me see here. When I show conjunctions, I want to show just in between this arrow here, show not between the arrow. Let me show MID, and I want to do this, and I want to do show let's also show the state here. Okay, now let's see modules, add inputs, map okay, and now this is initialize the false, and And now we have the memory here that 99, the last signal was low. Okay, conjunction models. They initially reach input. When a pulse is received, the conjunction module first updates its memory for that input. Then, if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. Okay, so this is the current state, except we are also gonna have the im.fromList. We're gonna map we just want all the okay, so this is the state. Init state is equal to now I want to say go. So I'm gonna have the current state, cur state. And I am going to say we're gonna have the counts of high pulses, high low pulses, low pulses, is equal to and then we have the Q and so I have to memorize this also at some point. Let me see. So then I can basically have like a scene of the current state. Scene ST. So if I don't have any pulses, I just return high pulses, low pulses. Go scene ST. It needs to be scene ST, cur ST, CHP, CLP. I don't care. No, so here I should actually loop. This is where I should loop. Okay. Let me see here. So I'm gonna say case cur state. Let me see. Scene ST cur state of nothing. Then I go. I am no map.insert cur state high pulses, low pulses. To 0. And I need map here also. Import data.map. Import qualified data.map as map. So Go is takes a map of int map module to int comma int. This is the memory, the memorization, to an int map module. Oh my god, this is really bad. Module to and int comma int and a list of int comma int. No, it's a list of pulses, and they need to be, I think, yeah, so they need to be high or low. Bool, and they return return a string. Seen as the map.insert curse state seen as the, let me import qualified data.map.strict actually. And I think it's actually okay. I also want to okay, now if I've seen it before, just php plp, I want to say let's do here just cp just r. I just want to show r comma cp. Okay, now this is the loop with the scene, and then we just figure out whether we're gonna look at the numbers after we see the example to see and figure the so it will take a while so it might not get into the initial state, but it might get into a repeating state, right? So let's see, go. HPLP. Okay, and then here we have a lost PID and P level, if it's high or low, is equal to and then we have the rest of the pulses. They should actually be a sequence because we're going to be adding to the end of it. Okay, So now we're gonna say we're gonna look up what it is. Let me see. Where? So CP prime is equal to if P level, if it's high, then HP plus 1 LP, else HP LP plus 1. Equal, so we can say case, and then we're gonna say a cur st im.bang PID of, and let me see, Hugo data.sequence. Let me see. So for now we're not. Let me see. Empty. And then we say here. Okay, now it's a sequence. Case cur state of IMP page of. So if we hit the broadcaster, when it receives a pulse, it sends the same pulse to all of its destination modules. PID of broadcaster. I don't care about the connections. Cons. So the logic from here is a is.from to list cons. How can I? Let's see. Oh, and I can just append. Okay, is2 list, and then seek. I'm gonna map a comma p level to this. Okay, and seek dot from list. So then I'm gonna just let n6 equal this in a go scene st car st cp prime pulses appended with n6. That was quite nice. Okay, now let's see what we do for flip-flop. Flips are either on or off. They are necessarily off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. It flips between on and off. If it was off, it turns on. So let's see. Flip-flop mid. So if it's ST S cons. So if S, if not S, then it is simply go scene ST cur ST CP prime pulses. So then we just ignore the pulse. Okay, we just ignore the pulse. It is ignored and nothing happens. If a flip-flop module receives a low pulse, let's see. So P level and not S. So let me see. Okay, so flip-flop modules are either on or off. They are initially off. Okay, if it receives a high pulse, it is ignored and nothing happens. Okay. So, however, if not P level, then if S, so if it's on, then they are either on or off. They are initially off. If a flip-flop module receives a high pulse, if a flip-flop module receives a low pulse, it flips between if it was off, then let n flip NFL is equal to flip-flop mid not as cons. I'm realizing now that this is going to be this is going to be like expensive. It would just be nicer if we could just track the flip-flop in a Boolean array or like Boolean thing directly and not have to look it up every time. But anyway, cur st is equal to im.insert mid NFL and sig is equal to if it was off, so this is going to be map not P level, not S. So if it was off, it should send a high pulse. It was on, it turns off and sends a low pulse. Okay. Let me write this nsig in go scene state cur sd prime cp prime pulses I am NFL. Okay, this is for the flip-flop, now for the conjunction. So first of all, let NC equal flip-flop. No, we're not going to change the flip-flop. We're going to say conjunction MID memprime cons. Now memprime and I need to remember who sent the pulse. PID, sender ID. Let's just say that the button sends from itself. That's okay. C comma mid C comma mid comma P level. So here it just does this. Here again, C to C comma SID comma not. I need to have the sender ID as well. Okay, so memprime. Remember they have the most recent pulse received from each of their connected modules. So it first updates its memory. Mem is im.insert sender ID P level. Mem. In undefined. I just want to get the nsig. I forgot to update the type here. Memprime is a new. Okay, we updated the memory. We updated the module. When a pulse is received, you can update the memory, and then if it remembers a high pulse for all inputs, and then let's update the current state. NC and so pulse is equal to and im.lms memprime. So the new pulse, so if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, so let's see, not and then nsig. It should be N6, I think. N6 always. And this should be I could probably do this in a nicer way, but let me see. Let nsig, comma 6 comma cur st prime equal, and then I don't have to do as much repetition, and then n6 in. So here I don't do anything. Here I also don't do anything. And here we are gonna say also n6 cur st prime, and then in go sin st cur st prime cp prime pulses n6. And let's see, they're always sending the same signal to all of them. No, this should be mid, actually. Mid. So what I want to say here is I want to say let m equal cur st im dot prime PID. Okay, and then I want to say here that cons is equal to connections m, and sender ID is equal to MID M, and then n6 is equal to seek dot from list of map c sid p p is.to list cons. Okay, and so I just want to send the updated state and the P level and the signal that it sends. Let's see. This should be just P level because sometimes they don't send a signal. Okay, n6 nothing is equal to seek dot empty just P. Okay, nothing, and the signal here is not as. is just not S. The signal here is just pulse. Okay, in P we can actually put these all in the where clause as well. I'm just gonna make this code nice and simple. Ding, 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 ding. Okay, so we update the state. Let me see here, we can say, we can just make this a card also. Flip-flop A is on equals S. Conjunction memory equals mem m. Okay, so now we've updated. Let's see. In its state now, let's see what it goes. Go and map.empty. Init state and a 0.0 and seek.singleton 0, 0, we send a low when we click the button. $44.8816. So pressing the button once Sends 4 and 8. Let's see, let's make this return int. We're gonna say RHP, so PHP, P LP, CHP, CLP, and we are just gonna say CHP minus PHP, comma, CLP minus PLP, and we have to multiply these together. Let's see. Let scene st prime equals in and button press equals this in button press. And I need to save also here. CP. Ooh. Current high pulses. Oh, right. Previous high pulses. I think I need to do like this, probably. So 32 times button press. So after pushing the button 1000 times, ooh. Okay, so it's not 1000 here. I have to multiply by 1000 times twice, times 2. Which is 1,000,000 actually. Let's create a new file, example 2. Key. Oh, output. Fitting. A multi. Okay, this module. The multi-input connection con if they both on sends a low pulse to the output module. Both sent to output. However, now that both of them are on and gone. An untyped module output. Okay, so Okay, so I guess if CST pulse ID, pulse level, pulses, case, not CST IM dot member PIT go STCST. Go scene ST cur ST prime cur ST CP prime pulses bit and cur ST. In the second example, I push the button 1,000 times. 4 250 low pulses and 2 7050 high pulses are sent. Okay, so this one is not working. Let's see for the second example. Ding, 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 ding. Doesn't work. So let's see. Show CP PP. Okay. So this is a bit more difficult, right? So the thing here is that PP so per cycle I just want to see also what it does for the input, if it's slow or not. I have the input here. Okay. Certainly taking a lot of time. To get the cables warmed up, the elves have pushed the button 1,000 times, including the pulses sent by the button itself. Yes, we also count that actually. Let's see. But for the second one, so it took 4 pushes. I think I need to remember how many times I've gone through the loop. Let me add that here. LP and num presses num let's have it there. We're gonna start this off with 0, and then here we're gonna say num ps plus 1, num ps num ps plus 1. Okay, it's not doing the thing. Let's see. Num ps let's actually just add it. Here. This is what we are tracking anyway. Oh, I was pressing too often. So this should be Okay, so after one press, so after one press, it returns to the initial state. And maybe what happens for the input is that it's always growing. Okay, so let's figure out the difference here. So PHP minus CHP, CLP minus PLP, and NPP minus NumPS minus NPP. This should be PLP and CLP. Now, so PP was the previous one. Yes, so CLP, CPP. So for every one press, we get. Okay, so then we have to take the length of the cycle is CL is equal to NumPS. A low per cycle is equal to this number. High per cycle is equal to this number. And then we're going to say P per C is equal to 1000 mod CL. So we're going to say here LPC times perc times HPC times perc. Oh. Oh, so this was NumPS minus NPP, right? Oops. I need to divide, I think. $1,168,7500. Okay, so it's HPT plus of, so, and these are the ones, so and then we do 100 mod CL, plus of times okay, no, let me wait with this off thing and just see. Okay, at least it works for the examples, but it is too slow for the input. And that's probably because we are it's probably because we are constantly updating this map. Ding, 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 ding. So cur st, let's make that let's make that just into the function that modifies the current one. Okay, f. So here we just have id. We don't want to make any modification. Here we define it as f flip-flop msc is equal to flip-flop m not as c. So then we don't do this cur st prime. We just define the function that modifies the current state. Okay, so here we update the current one. Okay, and then cur st prime is equal to im dot modify alter. Let me see. Modify int map. We should have a adjust. Adjust f mid change adjust modify mid change mid cur st. Okay. So here the modification is actually going to be f conjunction mid mem mc is equal to conjunction mem prime c, where mem prime is equal to im dot insert sit p level mem. Oh, and I need the mem prime here also. Okay, it's definitely not working for the input. So now we just do the adjustment. So we've kind of we freed ourselves from like, so now this function does not need to know about they don't need to know about the way you store it. Okay, now I want to change how the current state is. So now it's an int map of modules. Let me just customize the hash function here. Hash broadcaster 0 hash output Ding. I think I should let the common things be first. Oh, I need to take a quick break now. Actually, oh, sorry. And of course, this changes as well. Let me just finish this change here. This is clearly not fast enough. Takes too long time. So let me see here. Let me trace show. Oh, num ps. Import let's see how it's doing all the button presses. Oh. Let's see, case num ps is larger than or equal to 1000. Then we do CHP times CLP. Case, now let's just do like this. Where, let me copy paste this. So we don't do it twice. Seen before. So if it hasn't been seen before, then we can just do it like this. Okay, actually, let's just see what happens if we just do the loop. If it actually just does it correctly for the examples. No, it doesn't get them right. Ding, 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 ding. I think it's because I should start at 1. So there's 1 button press, right? Okay, so this is part 1. Let's just paste that in. This is not the best way to do it, because now they're going to push it 1,000,000 times. Okay, continue to part 2. The final machine responsible for moving the sand down to island has the module attached named RX. The machine turns on when a single low pulse is sent to RX. Reset all modules to their default states. Waiting for all pulses to be fully handled after each button press. What is the fewest number of button presses required to deliver a single low pulse to the module named RX? Okay. So it's just not at all, let me see. RXH is equal to hash RX. Nothing. I can still do this, but just to make it faster. But if in case there's a loop, I can't do it. So what happens otherwise is that it never resets, right? The state keeps changing, which is okay. So we had part 1 done. We were just trying to. It was premature optimization. Let me see. Case PID is equal to RXH and P not P level is equal to stop at 1,000. Part 1 and 2, stop at 1,000. So we have false, to false, ding 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 ding. Stop at 1,000. Part 1 and 2. Oh. True. False. Okay, it's taking a long time. Okay, let's just abandon maybe the caching. Let's first git commit day 20 part 1. Oh, git add day 20.hs example 2 input git commit. Oh, I should have. Okay, so let's see. Rx. So for Rx to get a signal, all of the inputs to LG need to be true. Let me see. Now we're gonna abandon this scene state thing. It doesn't actually work. Ding, 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 ding. Okay. Now this needs some different kind of analysis. Okay, now there's no init state. Let me see, how fast does it do all of them now? quite fast. Okay. Let me see. Test P level in. So the pulse let me see. Let's just change this to just be part 1. It would be nice if we had some tests for this, right? So we're gonna say part 2 here. Now, and I'm gonna remove all these. Oh, let's see. These are init state. Okay, so rxh is equal to hash rx map.bang rxh. Right. In my module, map.bang hash rx part 2 is a string to a module. I am key 120114 is not a member of the map. Okay, no wonder the other one didn't work. A hash rx. It's equal to Rx. Oh. Right, okay. Because Rx is not in the map. Okay. Let me see. Pit is equal to hash Rx. But SD1000. Let's see. Let's just copy paste this. And let's not stop at 1000. Ding, 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 ding. Part 2. Now here, I'm also not going to be counting the pulses. I'm just going to say num ps. Oh, and here we're not even pushing the button, so it's just NP. I don't need this ratio here anymore. I think I don't need to do this either. Except if P level, then make it slightly faster. but not enough to do much, I assume. What did I say if it was output? Hash output is 1. We just make a hash Rx is equal to 2. So we can check it for the, so let me see, 2 PID. Let's see, PID equals 1 or PID equals 2. And then we can do it with the example too, right? So since the A, since the in to con, right, and I need to and con let me see. We have conjunctions. So if you remember high pulses for all inputs, it sends a low pulse. And P cur state, cur ST TS. I just want to see what we get for the current state in the queue. The thing was that it never looped in the state. So he sent load to broadcaster, but then load to A, high to con. And then it sends low to A, and then it goes inside way. And then B sends high to con, and then con sends low to output. However, now that both flip-flops are on, heat map. This is output. Where skip equals go cur st np pulses. You see here, then skip. Oh, and now I'm just looping an example 2. Great. Okay, so this will eventually work, but it might take a lot of button presses. Hey, what is the question of today? Hey, Felix 3. Question of the day is day 20. We have these circuit stuff described like this. So you send signals high or low to any of these. And part 1 was to figure out how many high and low signals are sent in total. If you press a button, it sends a signal to the broadcaster, and the broadcaster sends, to its destinations, and then these are either conjunctions or flip-flops. So you send you send signals that are high and low. So flip-flops only activate if they're on, and then they flip off. And they have conjunctions, which can combine signals. So now I'm trying to, so that was the first part. Let's just count the signals. Second part is figure out when you send a signal to a specific one. So, okay, I think what I have to do is I have to figure out so in the input, I have to figure out when does LG activate. So our RX will activate. RX will activate when LG sends when all of LG's inputs are high. Right? So low pulse. So then if it remembers high pulses for all inputs, it sends a low pulse. Okay, so we're going to do this differently. And we're going to run it on example 2 as well. Okay, so this is the init state. This is not fast enough. So the init state. So let me see. So activation of a given gate. So str. So mod id is equal to so these are the con input actually. Let me see. So con input hash rx. So for Rx to activate, I need LG to activate. LG to be active. Let's see, so con input hash Rx. So these are the inputs to see con input Rx. So let's see, so activates. Okay, so con input, then map cur is so a modules map. Let's see, init st im.bang. Init state. I actually need to go for a meeting soon. Okay, so for Rx to activate, we need a high from all of these at the same time, right? So I think then we need to kind of figure out the modulus, right? When will all of them be at the same time in the high state? Okay, let So 2ag Rx is equal to 2ag Rx. Okay. Then 2ag Rx is equal map init state im.bang dot memory im.keys dot memory to rx to rx. To rx is a list of modules. Module right. Now for this is going to be map m. I'm going to see all of these. Okay, so we have again the case that it's a list of conjuncts. To ag to ag rx. Okay, let me see. To ag so we have a 2ag rx. We have 2ag rx. And then we're going to say map to ag to ag to ag rx. Let me see. LLL. We're gonna say map m. We're gonna print L. This is just the first one. Map m print L. Then put strln. Okay, do map m print ll. And then map m Hey, Matt Flash. What's up? Again, they are all they're all conjunctivists. Okay, to activate RX, I need to activate this one. To activate this one, I need to activate all of these. Okay, to activate all of these, I need to activate all of these at the same time. Let's keep going. Map. I want to see when do I get to something that's okay. These are all flip-flops. All right. Now I need to map M. So all of these flip-flops are send a message at the same time, then it activates. Okay, why do you not write types? It's just like func intent. I mean, I do it sometimes, right? But the power of Haskell is that it can actually infer a lot of it for me. Okay, we're almost there. We're gonna keep looking at this in a bit. I'm gonna take a break now. I have a meeting. But so what we have to figure out is how many button presses will it take for all of these to be on at the same time. I think that's a trick. All right, thank you for today. We saw part 1 at least. And yeah, I'll be back later today, but I have to take a quick meeting. See you in a bit. Okay. Hey, bye-bye. All right, we're back. Oh, sorry about that. Okay, we're still working on it. While I was hacking, I hacked a bit more, and we see that on the 3rd layer, it's all flip-flops. Let me see. So I just started concatenating. So let me see here. So it's 2 ACK RX. So see let's just say so TAA is 2 ACK 2 ACK module to module, and we're gonna do concat map Okay, so we are gonna say here, iterate to ack, take 1, iterate to ack, to ack rx. And then for the input, we are just going to say do L, so map M L M's do map M print ms Butster ln dot part2 dot lines. So we iterated, then we were basically getting the same. So then we get so take 2, take 3. Take 4. And all of these have to be sort. So all of these have to be active at the same time. So I think we're doing the GCM again here. Let me see. So now let's copy this one again. So the go again. From this one. Okay, so now let's no matching selector memory. Maybe I need to do 3. Right, okay. So now I'm just gonna say here. Okay, and now I'm gonna just map MID on all of these. So we have here flop is equal to all of these. Now go is here. We're not gonna stop here. we are just gonna loop right away in you can put this button press down into the where. Okay, here we are gonna, so we're not gonna say rxh. Let me see, and I want this skip also. So we're not gonna do anything here, but let me np I'm gonna write this as skip, and then we're just gonna say here skip. Otherwise, we're not gonna need these. $121, something's wrong. Okay. So now I'm going to say here flop on, and the flop goes on the flop goes on when it receives so flop. Okay, so pit is equal to flop. Okay, so this is a let's make this like this. A flop. It's still giving vibes. Okay, so I'm gonna now map a map go init state and then 1 I can actually put this button press. I'll actually have to put it here. 1 button press over flops. And so this is the number of button presses required for each flop to be on. And I think I take the greatest common multiple here. think that was from day 3 or something. Git grep GCM. Which day was it? Not day 2, day 3, day 2 maybe? Nope. Was it day 4? Maybe it was day 5. Almanac, transform all. Seeds. Nope. Day 6. Nope. Let me say git grep folder. Git grep. Folder 1 LCM. Okay, what's day 8? Yeah, okay. So let me see here. Folder 1 LCM. Day 20. So that's saying after 2048 presses. Maybe I need to take the product. Your answer is too high. Okay. It's not the product. Maybe I did too many concats. Let's see. Maybe I shouldn't do flops here. Okay. So this is the first level. Okay, and now we're gonna map to ag. Maybe I'm missing the map to ag. Okay. Map MID. Map go 1 is equal to go init state 1 button press. Now let's map go 1 so every 2048 cycles this one will be active, and every 2048 cycles this one will be active. Flops. Let's see. BF flops. Then we remove one level here. And we remove one level here, I think. So BF flops. So this is right before the flops. Let me see. So that is map, go 1. BF flops. took 2 number presses before they were all pressed. Let's see. BFF flops. But that one needs to be high. It's not enough to, yeah. Go 1 HL. HL. P level is equal to HL. And then we just need to add HL here and HL here. And HL should be here also. Map go 1. Here needs to be false. Oh. Okay, I need it. So HL and flop. Oh. HL flop. HL flop. Map go 1. True. Button press HL. Okay, yeah, I need to swap it here also. So here we want a low activation. Here we want a true. Okay. So flip-flops, if it was off, turns on and sends a high pulse. Okay. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. So for flops, we want them to receive a low pulse. Okay, so if it's BF flops, we're waiting for them to send a high pulse to all of their so in one round they all send I'm not quite buying this. Let me see. BFF. Then if it's similar, because here it is I'm okay, so how long does it take for it to send a high flop? That is the question. Okay, this is how long it takes for it to send a high flop. So before the flops, how long does it take for it to send a low flop? Because then all of them have to be active. Okay. That is surprising. Let me see. Is it just some here? Nice, it's just the sum. Okay. I think it's just some here also. Concat map. A concat map. Some concat map. Let me see here. Concat map. Okay, it doesn't want that. I think this might be the answer. Seems so low though, but it's too low. Okay, let's abandon this. Do we have the sum here again? So that's the answer to that one. Maybe for these ones, it's actually the product. So I want all of these to send a high signal so that PFFF map MID PFF flops. Map go one false PFF. I think it's probably then the product of those. All right. We got day 20 part 2. Whoop whoop. Took some guesswork, but let me see. Okay, so this is sum. And then this was a product. It's actually a product of all of these. So the idea is, okay, so this is the number of... So for the flops, you have to check... because they flip on and off, right? So then... every 3,851 cycles, they're all flip on at once, right? And now they all have to do this at the same time. So then it is the product of these numbers. Good. Status git add. Because git commit day 20 finished. Git status. Am I forgetting something? Example git add day 17. Example git commit add forgotten. Example. Do git push. Okay, so we did day 20. Tell me what you think about the solutions. And yeah, hope you had as much fun as I did. All right, thank you, and bye-bye.